Okay, now we're into part 4, so we're getting there. There's going to be one more part after this. In part 4, we want to look at some basics of problem solving, how to set up problems, and how to do simple unit conversions. So these are the types of calculations that we'll be doing throughout the semester. Just a brief overview here, and we will look at problems in detail as we get into different chapters. But be aware that getting to the point where you can set up an equation in a chemistry problem to solve it from a problem statement. So in other words, setting up an equation from a word problem, it's going to require good critical thinking skills. This is one of the most important skills any student can develop in a chemistry course. Especially critical for the chemical laboratory technology program. Critical thinking is one of the things that any employer is going to want to have in an employee, something you're really going to need to develop. There isn't a simple formula that applies to every problem. Trying to memorize formulas and just plug numbers into a formula, it's going to get you into trouble eventually. You won't know what formula to use, or you're going to apply it the wrong way. If you take the time to really learn some problem-solving strategies and start developing your chemical intuition, you're going to find yourself a lot better off when it comes to problem-solving in a real-world scenario. Some of the basic things you need to know in solving chemistry problems is, first of all, unit conversion is going to be your friend. Learning how to get from one unit to another is going to get you through a lot of the problems and the issues that you're going to find here. So if you think of the problems as unit conversion problems in which you're given one or more quantities and asked to convert them into different units and start developing your strategies for doing that, you're going to be way ahead of the game. Now, specific equation types. There are other problems that will require you to use very specific equations to get to the information you're trying to find. And so there, your problem-solving skills are still going to come in very handy, but that's going to require you to have knowledge of those specific equations. So you're going to need to know those or know how to find those. So when you're using something that we call dimensional analysis to convert from one unit to another. So for example, you're given something in the English imperial units of inches and you want to know what that is in centimeters. How are you going to go about that? You're going to use something called dimensional analysis. Now in dimensional analysis, units are going to be multiplied, divided, and canceled just like any other algebraic quantity. So, sorry, you do have to kind of know some algebra here. Okay, we're going to treat units as though they were sort of like variables. Using the units as a guide to solve the problem, rather than the numbers associated with them, that's your dimensional analysis. So, units are going to be key, not the numbers. Now, that doesn't mean you can ignore the numbers. You've always got to write every number with its associated unit, but you're going to start with the units and let the numbers follow those. Something a lot of chemistry students try to do that gets them into trouble is they try to set up a dimensional analysis with just the numbers. They leave the units out. Always, always, always include units in your calculation. Not just in the final answer, but within the calculation. Divide them and multiply them as if they were part of the algebraic equation, as if they were true values, because they are. They're real values. If you remember to do that, again, knowing unit analysis, dimensional analysis, can really save your skin. Don't let units appear or disappear in the calculations. So those units have to make sense all the way from beginning to end. So just kind of a generic example or setup of that. If you're going to carry out what we call a conversion problem, you want to convert from a given unit to a new desired different unit. Okay, we're given a quantity in some unit, we're going to convert it. It's going to take on this form. Here's the information that we're given, and then we're going to have something known as a conversion factor. And we'll talk about what a conversion factor is. That is going to lead you to the information that you want. So here's a given unit. Okay? Now, if you remember in algebra, if I have a ratio, if I have a numerator and a denominator, and I have the same thing in the numerator and the denominator, they cancel out. So the given unit here would be in the numerator. I can imagine that it's over 1. Given unit in the denominator, those cancel out. That leaves me with the desired unit here. That's what my final answer will be. So what I need to know is what's the relationship between the given unit and the desired unit. That is the conversion factor. So, for example, as I said, inches to centimeters. Conversion factors are going to be constructed from any two quantities that we know to be equivalent. Now, if you're using the Conceptual Chemistry website, as I would highly encourage you to do, those are free points sitting out there, and Dr. Suhaki has wonderful, wonderful video explanations, much better than I've got here, of some of these. Okay, so maybe a little more palatable. And he talks about those conversion factors, about how you have something equal to 1. So you can construct a conversion factor by making sure when you divide both sides of the equality by 1, okay, or by each other, it ends up being 1. So we've already said that an inch is equal to 2.54 centimeters exactly. I have an equality, okay? So if I have these being equivalent, or I have an equality, if I divide both sides by 1 inch by 1 inch, that's just 1. 2.54 centimeters divided by 1 inch, there's my conversion factor. That quantity I've already shown is equal to 1, so now I can use that to convert between the units that I am given, inches, and the units that I want, centimeters. Alright, so here's our example. Now when we're solving problems, it's great to use dimensional analysis, it's great to set those units up, show them canceling out. Always check your final units. Make sure the final units you're left with are the ones you want, and stop and think about, does the number make sense? If I'm told that I have 44.7 centimeters, I've got my conversion factor, and I can put this either way, and it shows that right down here. I can put the 2.54 on the top or the bottom. Doesn't matter as long as I make sure this unit stays with it. Centimeter, centimeter. Now in this case, I want centimeters to cancel out. I started with centimeters. So I'm going to put the centimeters down here so that numerator, denominator cancel out. And then I've got my 44.7, my 2.54. I've got 1 up here. When I divide that out, I end up with 17.6 inches. That's the only unit that's left. Okay. And I stop and think, does that make sense? So I started with 44.7 centimeters. There are more centimeters than there are inches, so I should probably end up with fewer inches than I had centimeters, and sure enough I did, by about 1/3. So that makes sense, that's good. Something else you can do to help with that process is create what is known as a solution map. Now, a solution map is just a visual outline that shows a strategic route that is required to solve a problem. It's basically mapping out your logic process, your thought process. For unit conversion, the solution map is going to focus on the units. As I said, units are key here. They're going to trump. A solution map for converting from inches to centimeters would go like this. So this is the critical thinking part. This is reflecting on what do I know and how do I know that. I've started with inches. I want to get to centimeters. I have a relationship. Here's my relationship between centimeters and inches. Okay. Now if I want to go inches to centimeters, here's the process. Inch cancels out, leaves me with centimeters. The other way around, from centimeters to inches, I just flipped that conversion factor over. So, a general problem-solving strategy that you can use, identify your starting point. What information are you given? You can even write that down. Given and then list everything you know under that. Identify your endpoint. What do I want to know? What do I need to find? Question mark, however you want to identify that. Now start trying to come up with a roadmap to get from your starting point to the end point using what you're given, as well as any other information you can get your hands on. What can you look up? What do you already know? What are those conversion factors? If you know that there are 100 centimeters in a meter, you can use that. Okay? Or you may be given a piece of information like 1 kilogram weighs 2.2 pounds. Use those pieces of information as well. You set up a solution map to diagram the steps to get from the starting point to the end point, and you end up with your final answer. So what are you given? How am I going to find the answer and then actually carry out finding the answer? Okay, just very general problem-solving strategies. Okay. And then you're going to sort it out. Okay, sort the information in the problem, strategize, get your solution map made out, carry out your mathematical operations, do your math problems and solve for it, cancel units as needed, and then check your final answer. Does this answer make sense? Does it make physical sense? Are the units correct? Okay. So we'll assign some homework problems that let you get a little bit of practice at that, and then when we meet for recitation on Friday, we'll do some more hands-on together as a group. Now, when you have more than one step you need to carry out, you may need more than one conversion factor with the units from the previous step in the denominator and then units of the following step in the numerator. So for example, let's say instead of going from centimeters to inches, you want to go to feet. Now, I don't have anything that directly relates centimeters to feet, but I do have the conversion factor that relates centimeters to inches, and I have one that relates inches to feet. There are 12 inches in a foot. So I may need an intermediate step. If I were asked to convert from centimeters to feet, I'd have to write down what do I know, and hopefully I would write down these two conversion factors, and then I could see the relationship. Aha! So if I start with the first one, it gets rid of the centimeters that I don't want, and it leaves me with inches. Well, I didn't really want inches, but now if I keep going, I can use this one to cancel out the inches that I don't want, and it leaves me with feet. And there I go, finished with that. In practice, how I would set that up, let's say I was given 194 centimeters. Okay. So what I'm going to do is set up a conversion factor. I'm going to write the centimeters first. Put the centimeters in the bottom and the inches on the top, and then the numbers follow along. 2.54 always goes with centimeters, 1 goes with inches. Now just the units cancel out. Centimeter, centimeter. Now I have inches left. I would use the second conversion factor. I want inches now to cancel out, so I put those down here. I put feet up here, and then I fill in the numbers. It is 1 foot, 12 inches. The inches are now going to cancel out, so they're gone. The only unit I'm left with is feet, and that's what I want. I want feet. Okay. Then I can carry out my mathematical problem. 194 times 1 times 1, so I have 194 on top. Then I'm going to divide that number by 2.54, and then whatever that answer is, I'm going to divide it again by 12. Now be careful when you're putting things in your calculator not to make the mistake of saying 194 times 1 divided by 2.54 times 12. Okay, unless you put that in parentheses, that won't work. So divide by, divide by. The number I get, 6.3648 feet. Now, that is without looking at your significant figures. If you look at your significant figures, 3 here, this is exact, and this is exact. So only my initial number affects that. I would go 6.36. I would round it off right here. And just one more thing to be aware of. Occasionally you may have to convert a quantity with units raised to a power, such as volume units. So if you are starting with a unit that is raised to a power, the conversion factor also has to be raised to that power. So for example, if I am given a volume of 1255 cubic centimeters cubed, and I want to know how many cubic inches that would be, the first thing I'm going to have to do is put in my conversion just from inches to centimeters right here. 2.54 centimeters is equal to 1 inch. But now I know I'm going to need to cube that, so I cube over here. Whatever I do to one side, have to do to the other. Okay? So now that cube is on the outside of the parenthesis. That carries through both the number and the unit. So I would have to cube 2.54, right here, cubed, and centimeters, cubed. I would have to cube the 1, right here, and the inches. Right, so when I cube the numbers, 16.387 centimeters cubed, 1 inch cubed. Now I can plug that in and get my final answer. Okay? So I have to be careful when I'm dealing with volumes, when I'm dealing with area or volume, squared or cubed. Whatever I use there, the conversion factor has to go that way as well. All right, so again, very brief overview into dimensional analysis and problem-solving strategies. We'll get plenty of practice with that, working problems in class, working problems during the lecture portion. If you have trouble with it, let me know.